All right, hi folks. This is Larry Mussolino. I wanted to do a few examples from the Module 4 homework in my labs to help you get started. Let's take a look here, number 1. So this problem is asking us to look at a joint probability distribution function of x and y, and it's giving us this probability density function. And it's telling us x takes on these specific values, y takes on these specific values. And so they're asking us to find the probability that x is less than or equal to 6 and y equals 6. So what I want to do for this is I want to look at all the combinations of x and y that satisfy this criteria. And what I'm going to do then is work out the probability function for that and add those results together. Here's what I mean. Let's work with x less than or equal to 6. Let me write down the x values that apply here. Well, for x to be less than or equal to 6, x could be 4 or 5 or 6. The y value is fixed at 6. So I'm going to write all these combinations. I'm going to take the x value of 4, match it up with the y value of 6. I'm going to take the x value of 5, match it up with a 6. And then I'm going to take the x value of 6 and match it up with the y value of 6. So these are all the combinations of x and y that match this criteria in this probability statement. Well, now I'm just going to calculate the fraction for each one of these. Here's our function of x and y. So for this first one, this is going to be 4 plus 6 over 126. The second one is going to be 5 plus 6 over 126. And for the third, it's going to be 6 plus 6 over 126. Now I can just work this out. So this is 10 over 126 plus 11 over 126 plus 12 over 126. And I'll work this out. The answer says simplify your answer. So we're going to have to simplify fractions. So if I work this out, let's say we got 21 and 12. I think that's 33. And I think we can divide top and bottom by 3. So we're ending up with 11 over 42 for that one. All right, so this is part A. Let's do part B. So in the same kind of way, I'm going to try to list out all the combinations. It says here, x has to be greater than 6. Well, for x to be greater than 6, there's only one value of x that satisfies that. X is 7. And y has to be less than or equal to 5. So that means y is a 4 or 5. So I'm going to list all these combinations then. For part B, I'm going to have 7 and 4 and a 7 and 5. This is 11. Oh, wait, let's add it. 7 plus 4 over 126. And this is 7 plus 5 over 126. So we have 11 over 126 plus 12 over 126. So that's 23 over 126. And I don't think that can be simplified. So I think that's the answer on that one. All right, let's go to part C. Part C says, what's the probability that x is greater than y? So I need all the combinations where the x value is greater than the y value. Let's start out here. Let me see. How about when x is 4? Well, if x is 4, there's no cases where 4 is going to be greater than the y value, right? Because the y value is 4, 5, or 6. So x equal 4 doesn't generate any results. How about let's go to x equal 5. Well, I could match an x value of 5 with a y value of 4, because in that case, the x value is greater than the y. All right, let's go to x equals 6. Well, when x is 6, I could match that up with a y value of 4 and a y value of 5. In both of these examples, the x is greater than the y. And then finally, let's do x equals 7. When x is 7, that's going to be greater than a y value of 4 greater than a y value of 5, and greater than a y value of 6. And I'm just going to add these together. I'll just write out a few of these. This is going to be 5 plus 4 over 126. This is going to be 6 plus 4 over 126, 6 plus 5 over 126, etc. And then you would just add those together. All right, how about part D? It says the probability where the x value plus the y value equals 12. So I need to pick an x and y combination where the values add up to 12. Well, if you think about it, the only possibilities are going to be what, when x is 6 and y is 6, and then when x is 7 and y is 5. Right? Those two examples, the x and y values add up to 12. So this is going to be 6 plus 6 over 126, 7 plus 5 over 126. This is going to be 12 over 126 plus 12 over 126. So we end up with 24 over 126. We have to simplify fractions here. So I think we can divide top and bottom by 6, I think. Yep. And that gets us 4 over 21 is the answer on that one. So for this example, what we had to do is list out the x and y values that satisfy the probability specification. And then we can go ahead and use this probability density function to figure out the corresponding probabilities and then add those together. All right, so that's this one. That's number 1. So let's take a look at this one. This is number 2 on the homework. It says, suppose x and y. Oops. Let me share again. Whoops. Okay, so this problem says, suppose x and y have a joint probability distribution shown in this table. Part A is find the marginal distribution of x. So of course we have to know, what do they mean when they say the marginal distribution for x? Well, what that means is sum up the values of this density function according to values of x. I'll say over values of x. So what that means is we want to, let's take this x value of 2. We want to sum up the values for f of 2 for all of the y values, across all the y values. What I mean by that is we want to take f of 2 comma 1, because that's the first y value, plus f of 2 comma 3, plus f of 2 comma 5. This is for part A of the question. Well, these values I can get right from the table. F of 2 comma 1 is given to me in the table as 0.084. F of 2 comma 3 is 0.129. And F of 2 comma 5 is 0.087. If I add these up, these work out to be 0.30. So when x is 2, we're entering the answer is 0.30. All right, let's find the other x value where x is 4. So we want to know, what is f of 4 across all the y values? So that's going to be f of 4 comma 1, 4 comma 3, and 4 comma 5. Right? Because we're summing up the values over x, we're keeping x to be this value 4. All right, again, I'm just going to read these off the table. 0.196, 0.301, 0.203. And if I add these together, it works out to be 0.70. So when x is 4, this marginal distribution turns out to be 0.7. All right, so the key to this is we summed up the values of the probability distribution function over the values of x for part A. Let's go to part B. Part B says, find the marginal distribution for y. Well, for that, we're going to sum up the values of this joint function over the values of y now. So let's start out with this y value of 1. So what I want to know now is I'm going to fix y to be 1, but I'm going to vary across all the values of x. So this is going to be f of 2, 1 and f of 4, 1. Well, I'll get these out of the table. 2, 1 is 0.084, and this is 0.196. And if I add these together, it adds up to 0.28. So when y takes on the value 1, we're getting the result 0.28. We go to the next row. Now y is 3. So I'm going to work out all of the values where y is fixed to be 3. So this is going to be 2, 3 and 4, 3. And I'll get these right from the table. 0.129 plus 0.301. And if I work that out, is 0.43. So when y is 3, the sum is 0.43. Last one, fix the y value be 5. So this is going to be f of 2, 5 and 4, 5. And I'll get these values right from the table. 0.087 plus 0.203. That works out to be 0.29. So there it is, 0.29. All right, so you notice when we were finding the marginal distribution of x, we were basically adding down the columns. But when we're finding the marginal distribution of y, we were adding across the rows. Okay, and of course you have to pick the correct format in this MyLabs problem. Then enter your answers in the blue boxes. All right, let's take a look at another example. All right, folks, let's take a look at another example here. This is question number 3. So it's giving us a joint density function. Here it is. And the question is, find the probability that y varies between 4 and 7 on the condition that x equals 1. All right, well, and I have to be careful here because this density function is only valid when x is between 0 and 6 and y is between 6 and 8. So I got to take that into account when we set up the integration. Let's start with the basic formula that says when you want to know the probability that, let's say, y varies between a and b on the condition that x equals a specific number. Here, x equals 1 in our example. We're going to want to integrate from a to b this density function y given x dy. So this is a formula from the textbook that we'll need for this example. So what we need then is this density function f of y given x. Well, there's a formula for that. If you want to know f of y given x, we have to calculate f of x comma y over g of x. G of x is the marginal density function. I'll say the marginal distribution of x alone. So we got to find g of x first. So let's call this step 1. We have to find g of x. So g of x is the integral of f xy dy. All right. And we're going to let this vary over y, which in our example is going from 6 to 8. So this is going to be an integral from 6 to 8. All right, so let's work it out. So it's the integral from 6 to 8 of 10 minus x minus y over 8 dy. Okay. And when we work this out, it's going to turn out this is going to lead us to a function in x. So our answer here is going to be a function of x. But let's work it out. All right. Maybe the first thing I'm going to do is going to pull that 8 in the denominator, pull that out in front because that'll make this easier. So I'm just pulling the 8 out in front now. Let's go ahead and do the integration. All right. So this is going to be 1/8. So now I'm taking the integral of 10 dy. That's 10y. And I'm taking the integral of x. Now remember, we're taking the integral of x with respect to y. So it's really like x is a constant here. So that integral is xy. And finally, I'm taking the integral of y dy, which is y squared over 2. And we have to evaluate this from 60. All right, so let me start out plugging in 8, the upper limit of 8 into this expression. So this is going to be 1/8. All right, I'm going to have 10 times 8 minus 8x. Remember, I'm placing each one of these y's with an 8 minus 64/2. All right, and now I'm going to subtract when I plug in the lower bound of 6. So this is going to be 10 times 6 minus 6x minus 6 squared over 2. I'll just write this as 36. All right, so this is a little messy, but let's keep going. Let's see what we got here. I'll keep this, let's do this in green. This is 80 minus 8x minus 32. And in the second parenthesis, 60 minus 6x minus 18. All right, well, let's see here. Then we got 80 subtract 60. So that's going to be a 20. We have a negative 8x plus 6x. Remember, the subtraction in front of the parentheses is going to flip the sign. So this negative 6x is really going to be a plus 6x. Negative 8x plus 6x is a negative 2x. And then we have a negative 32 plus 18. Negative 32 plus 18 is 14, I think. Yeah. Minus 14. So this is, I'll keep going down here. This is 1/8, 6 minus 2x. And let me factor out a 2 from the top. So the top is 2 times 3 minus x over 8. But the 2 and the 8 cancel out to give me a 4. So I'm left with 3 minus x over 4. All right, so after all this work, we just figured out that the g of x function is 3 minus x over 4. All right, let me write that up here so we have it. So we just figured out that the g of x function, let me erase this. We just worked out that the g of x function is 3 minus x over 4. All right, well, now we can come back to this equation because now I can plug in and work out this f of y given x. So let me get rid of some of this. Okay. So let's go ahead and work that out. And then after we do that, we'll have one more integral to work out to get our final answer. All right, so let me come to this. So we want, because remember, we're trying to get to this point right here. We're trying to evaluate this. Before we can do that, we need this f of y given x. So that's what we're going to work out right now. Y given x. All right, it says take the original density function. That was 10 minus x minus y over 8. I'm getting that from back here. And I got to divide it by g of x. Well, g of x on the bottom is our 3 minus x over 4. All right, well, this is dividing one fraction by another, so I'm just going to keep the first fraction and flip the second fraction upside down. So I'm going to multiply that by 4 over 3 minus x. Let's see, this 4 and this 8 cancels out, leaving me a 2 on the bottom. So here's what I'm left with, 10 minus x minus y over 6 minus 2x on the bottom. All right, so this is the function we need. And so let's go back to last step. We want to know, here's what they're asking us. What is the probability for less than y less than 7, given that x equals 1? All right, well, according to what we wrote up here, we're going to take the integral. Now, you might be tempted to write this as integral from 4 to 7. But here's where I got to be careful. The y values only are allowed to range from 6 to 8. So instead of writing this as a 4, I have to make this a 6. Because that's the valid interval for y in this probability density function. And I need this f of y given x that we just worked out. So it's going to be 10 minus x minus y over 6 minus 2x. This is all under the condition that x equals 1. So I can plug in x equal 1 here. All right, so here's what I got. The integral from 6 to 7 of 10 minus 1 minus y over 6 minus 2 times 1 dy. So I just replaced this x equal 1 for this x value here. All right, here's what we got then. The integral from 6 to 7, 9 minus y over 4 dy. Let me bring the 1/4 out in front. So this is what we have. All right, well, this is an integral I think we can work out. So this is 1/4. The integral of 9 dy is just 9y. And the integral of y dy is a y squared, evaluating from 6 to 7. All right, so let's plug this in. I'm going to write it up here maybe. So it's 1/4. I'm going to plug in 7 to get started. That's going to be 9 times 7 minus 7 squared. Now I'm going to plug in the 6. So that's going to be 9 times 6 minus 6 squared. All right, so this is 1/4. What do we have here? 63 minus 49 minus 54 minus 36. All right, let's work this out. I guess I'm going to go to my calculator here. So let's see, 63 minus 49. This is 14. And 54 minus 36 is 18. Let me double check this here. You know what? I made a mistake here because when I integrated y, this should have been y squared over 2. Whoops, my mistake there. So this should be 49 over 2, and this should be 36 over 2. All right, so let's figure this out. Again, I'm going to go to my calculator. And I'm just going to work out what's in these brackets here on my calculator. And if I work that out, if I work out on my calculator, this works out to be 5/2. And then I have 1/4 times 5/2, so 5/8 looks like the final answer on this one. All right, folks, there were multiple steps we had to follow here. We were basically trying to evaluate this integral to get the answer. Before I can evaluate that integral, though, I have to work out this, this density function of f of y given x. Well, this is the formula we need. You have to take the joint density function and divide by g of x. Folks, hope this is helpful as you're working in Module 4. I'll try to record another video with some more problems from Module 4 a little later.